Welcome to another video on design pattern. In this video, I'm going to talk about parallelization. So let's get started. So this design pattern called parallelization is very simple, which means if you can think of any task which can be divided into subtasks, and all those subtasks can be executed in parallel. Now, what is the use case we are talking here is a stock data analysis. So in the stock data analysis is about we are looking into multiple sources of a given stock. So like annual report, we have then investor data, we have a presentation, we have external agencies doing credit rating for that particular company, and then we have a financial data like which is structured data, and lot more sources are available. So what I can do is I need all the data for me to actually generate a report, which is analysis, and then generating the recommendation report. Now, if I can do all this research or fetching of the data in parallel, then I can save a lot of time, right? So that is what this use case is about. So let's take a look how I will actually implement it. Very simple. Let's say the query comes where user is asking, can you analyze Tesla's financial performance and investment potential? I'm considering buying their stock and want to understand if it is a good investment right now. Now we have a stock analyst agent, which has some component, which is a LLM based component, where it will break the query and see, break the query and understand that this person or the user is asking about complete analysis of given stock. It means whatever sources I have or I have configured to or access to, I should be invoking all the sources, collect all the data from all these sources, and then synthesize the information and generate the report. So that's what it will do. It will generate all these requests in parallel. 1, 2, 3. So all requests will be generated in parallel, and one request will get annual report data, another one will get earnings call data, third one will get company's presentation, which is companies are actually preparing a presentation for investors. So get company presentation data, and these all tools, these are all acting as the tools, will make call to external system, because this is not a scope of agent application. This data is not within agent application, this is outside. So these will make call to APIs. Let's say some APIs hosted, or someone is exposing this data in a form of APIs. So that's what we are going to call. Get this all the data together, give it back to LLM. Now LLM will aggregate the data, aggregate the results. So that's the aggregation here. And then once the data is aggregated, give it to another LLM, which is supposed to generate a report. So it means there's another LLM with another role in this whole system, which is the stock analyst agent system, which is going to take all the data and prepare a report by making a structured output. Like and that is maybe one example is very simple. So first of all, it will just say the buy, the recommendation is buy rating is this, strengths, these are all strengths area, and then recommendation start with small position and target as a stop loss this. So that's what that's a real outcome we are looking for, because that's what today we see, how systems like whoever is recommending these stocks, they actually come up with these points and then the stop loss and the target price. But all the activities are done in very manual today. Maybe they have access to the system, but someone has to look into the data, manually read those documents, make some understanding, and use their past knowledge or their tribal knowledge, whatever they have been gaining through this industry of financial markets, and then apply that learning into this generation of the report. But now AI can do this. Yes, one thing is important here. The data is super important, which we are giving to the agent, and then intelligence to get insights from the data. So which is available also with models like Claude these days. We have seen the capabilities of Claude where it is able to actually do detailed financial analysis. I think I remember I was using one of the application, like a very well-known application like a Perplexity financial agent, where they were able to demonstrate that how they used their search data about a given stock, and then these proprietary model. I think they used one of the proprietary model. I'm not sure about that, which model was that, but assume that this was probably GPT or Claude, one of them. So they were able to leverage the capability of the LLM to understand the data and get some insights, which generally as a human I can only do if I have a intelligence or have a domain understanding, financial market domain understanding. So that's what we are trying to leverage here. So this is the simple parallelization pattern, but very design pattern, but very powerful for these complex use cases. So thanks for watching it. So stay tuned and I'll get with another video soon.